Hello. In this discussion, we're going to get a little bit more practice with the cosecant and the secant graphs. We are actually going to put a period compression or stretch based on omega, what omega is, and we may be doing some that has B, which is a vertical shift up or down. All right. So let's begin with this example. We're going to graph y equals negative cosecant of 2x minus 1. And use that graph to determine the domain in the range of the negative cosecant of 2x minus 1. Okay, so once we get the graph complete, we're going to identify the domain in the range. Now, in order to graph this equation, I'm going to begin with using sine. Okay, the sine graph is what I'm going to do. It's going to have the same parameters as this one. And that's what it looks like. So we have a negative sine of 2x. That's what it looks like. Now, the minus 1, I'll deal with that later. That just brings the graph down 1 unit. So if you notice on the sine, the period is going to be pi because it's going to be 2 pi over 2. So it completes one cycle in pi units. So that's where it ends at pi, and it starts over again. The negative just tells me it turns upside down. It's a vertical reflection, remember? That's why the sine's inverted. This graph is inverted because of the negative that's out front. Okay, so that's the shape of a negative sine of 2x. Now, the cosecant is going to be negative cosecant of 2x. Now, notice where the first graph had their x-intercepts at 0, pi over 2, and pi. So that's going to be where my vertical asymptotes are located, at 0, pi over 2, and pi. Okay, so notice the lower valley down in the fourth quadrant. So on the negative sine of 2x, well, it's going to be a branch that opens down. Now between pi over 2 and pi, there is a peak there. So there's going to be an upper branch at the top. So that is a negative cosecant of 2x. So first thing I did was I did a negative sine of 2x. Locate the period, which is 2 pi over 2, which is pi. It's inverted. Then I take that graph and look at the x-intercepts, 0, pi over 2, and pi. I place vertical asymptotes there. And when there is a bottom valley, there's going to be a bottom ridge or bottom peak. And when there is on a sine curve, when there's a peak up there, there's going to be basically a little mini parabola that opens up. Or what I call an upper branch. So lower valleys gives you lower branches, and upper peaks will give you upper branches. That's the simplest way I can probably tell you there. Now we're not done. We're close. We got y equals negative cosecant of 2x. Now what's left to do? The minus 1. So you take all these branches and then you bring them down by 1 unit. So that's the ultimate graph right there. So the graph goes down 1 unit. So that one at upper branch was up there at 1 will now be hitting the x-axis. The one that lower branch is its highest point at negative is that negative 1 in that middle picture. It's going to be negative 2 in the final picture. All right? So that's the shape of this function. All right? So that's going to be negative cosecant of 2x minus 1. So notice I don't try to gobble up too much at one time. I do the negative sine of 2x first, see what that shape is, and I do that so I can find out where the x-intercepts are. The moment I find the x-intercepts, then I can place my vertical asymptotes, and that's kind of tells me where I place my branches at, because I place my branches in between my vertical asymptotes. So I do the sine to find the x-intercepts. I find the x-intercepts to find the vertical asymptotes. I find the vertical asymptotes to know where to place my branches at. That's the reasoning behind it. Okay? Last thing to do is look at that final picture and tell me what the domain and the range are. Well, the domain is all real numbers except multiples of pi over 2. So it's not defined at pi over 2. It's not defined at pi. So where you find a vertical asymptote, it's pi over 2 times k. So it's every 90 degrees. In other words, there's a vertical asymptote. And the range, just look at the graph. It looks like everything is defined except between negative 2 and 0. So there's a graph. If you start at the bottom, it goes negative infinity to negative 2, and then it starts up again at 0 to infinity. So the range is negative infinity to negative 2, and then 0 to infinity. Now note the brackets. There are brackets on these endpoints because there is numbers there. So the graph does hit 0. The graph does hit negative 2. So that's why it includes those. Okay? So, but as I said, to graph a negative cosecant or to graph a cosecant or secant, do the primary function first, locate the x-intercepts, draw vertical asymptotes there, and then using the graph of the sine or the cosine, put branches down as where your peaks and valleys are going to be located. So again, if you have a peak, then you will have an upper branch. If you have a valley on your sine or cosine curve, you will have a lower branch. So that's how they work. So if you have any questions regarding this, you let me know, and we can do some more examples. And you have a good day.